So I'm interested in finding out what good reasons for ascribing consciousness to artificial systems would be, and what reasons there would be to infer that a system is non-conscious. And when we try to infer the presence of consciousness, so if I start with myself, I can be relatively confident that I'm conscious and also that you in this room are conscious. And if we then go to other animals and even insects, the confidence decreases. And when it comes to artificial systems like robots, artificial neural networks, computer chips, or brain organoids, there's an increasing amount of uncertainty about consciousness. And we already heard in Henry's keynote lecture this morning that there are also a lot of divergent views in consciousness science, so we cannot really expect theories of consciousness to converge on a single theory that would then be applicable to artificial systems as well and settle the question which types of artificial systems could be conscious. But that doesn't mean that theories of consciousness are not useful. So there is this AI consciousness report that Henry also mentioned, which was published last year by Patrick Butlin, Robert Long, and a huge number of further authors. And in this report, they say, we would derive a list of indicator properties from a survey of theories of consciousness. And our claim is that AI systems which possess more of the indicator properties are more likely to be conscious. To judge whether an existing or proposed AI system is a serious candidate for consciousness, one should assess whether it has or would have these properties. So the idea is not that we can derive a single indicator or construct a single test for consciousness in an artificial system, because there's no smoking gun. Instead, we just have to look for different pieces of evidence that might speak in favor of the presence of consciousness. And the idea of the methodology in this report seems to be that if we find more pieces of evidence, more positive indicators of consciousness in a system, it makes it more probable that the system is conscious, as opposed to a system which displays fewer indicators. Okay, just as a reminder, so some indicators of consciousness that would be reliable in the case of human beings, of course, are not reliable in the case of artificial systems. So assume there's a non-responsive human being, a patient, and we connect it to a computer via a brain-computer interface. And let's suppose the person is able to issue a report. I want everyone to understand that I'm conscious. In the case of a human being, this would be strong evidence for the presence of consciousness. But as the case of Blake Lim 1 shows, in the case of large language models, this is not strong evidence. And Henry also mentioned Susan Schneider, who kind of predicted that something like this could happen. So a few years ago, she wrote, "Even today's robots can be programmed to make convincing utterances about consciousness, and a highly intelligent machine could perhaps even use information about neurophysiology to infer the presence of consciousness in biological creatures." So while there are some indicators of consciousness that provide strong evidence for consciousness in the case of human beings, that's because there are certain requirements that are fulfilled by human beings but are not necessarily fulfilled by artificial systems. Does that mean that these indicators cannot be used at all in the case of artificial systems? Well, so there's a nice paper by Leonard Dung, who's also giving a talk later at this conference, in which he argues that, well, in general, we can use tests of animal consciousness as tests of machine consciousness. So the mere fact that there are some artificial systems for which reliable indicators cease to be reliable doesn't mean that they cannot be used in general. So basically, for every system, we have to determine, okay, is this indicator reliable in this context or not? And he says that, or the way he puts it is that we have to determine whether the AI was constructed to specifically exhibit an indicator, and in that case he calls this an ad hoc system, or a gerrymandered AI, or AI resulting from gaming. And just gonna skip this. Now, when it comes to large language models, of course, it's not the case that they have been intentionally designed to display some indicators of consciousness. Maybe some recent versions, of course, are designed in such a way that they don't display such indicators, that they don't say they're conscious. But even if they do say they might be conscious, that's not because they have been gerrymandered explicitly to do this, but still we can regard this as a form of gaming these indicators. So in his recent book, Jonathan Birch points out that it's a situation in which we should expect a form of gaming, that is, that indicators are displayed for the wrong reasons, not because the systems are actually conscious. And that's not because the AI intends to deceive, but because it's designed to produce text that mimics as closely as possible what a human might say in response to the same prompt. And in service of that goal, we should expect it to use its knowledge of what humans typically say when asked about their feelings. So even without an intention to display such an indicator, these systems may may game the indicator or be ad hoc with respect to some indicator. Okay, let me briefly take stock. So there's increasing uncertainty about inferring the presence of consciousness, and for any individual indicator, there's the gaming problem, namely that reliable positive indicators in human beings that provide positive evidence for the presence of consciousness need not be reliable in artificial systems. Self-reports are one example. And now, one way to try and deal with this challenge that comes from the gaming problem is to find out what the difference is between human beings or other animals and certain artificial systems that makes these indicators reliable in the case of human beings, but not reliable in the case of artificial systems. So there seem to be some requirements that are fulfilled by human beings that make certain indicators reliable, and maybe some additional requirements on being conscious. Maybe there are some general constraints on being conscious. Maybe you need a body or agency for being conscious, or there could be other general constraints on implementing consciousness in artificial systems. So if we want to confidently infer the presence of consciousness, we have to see what are these requirements or general constraints. And I call these negative indicators because they're such that their absence is in general more informative than their presence. So if we take recurrent processing as an example of a general constraint on consciousness, the mere presence of recurrent processing in a system does not provide strong positive evidence for the presence of consciousness, but if it's actually necessary for consciousness, then its absence provides a lot of information, because that would allow you to rule out that the system is conscious. And similarly, there are some negative indicators that are such that if they are not present, they allow you to rule out that a certain positive indicator is reliable. So I call these indirect and direct negative indicators. Indirect indicators, negative indicators, are such that there are requirements on making positive indicators reliable. And direct negative indicators are general constraints on artificial consciousness that are such that their absence speaks against the presence of consciousness, regardless of which other indicators are present. And if a system does display these negative indicators, this would also mean that positive indicators are reliable in that context. Okay, just to briefly repeat, positive indicators are probability-raising factors. Their presence makes it more probable that a system is conscious. Indirect negative indicators affect to what extent positive indicators are probability-raising. Self-reports in artificial systems in large language models are not that reliable because they fail to display some indirect negative indicators, whatever they are. Some requirements are not fulfilled. And direct negative indicators are general constraints on artificial consciousness, for example, plausible necessary conditions that are such that their absence is probability lowering. If a system fails to display such a direct negative indicator, this makes it less probable that the system is conscious. Okay, now we can ask many questions about negative indicators. What are sources of indicators? How can they be justified? And what I want to focus on here is how can positive and negative indicators inform credences, that is, degrees of belief or subjective probabilities that a given system is conscious. And in the AI consciousness report, actually, there is a passage in which they suggest how this can be done. So they say systems that have more of these features, more positive indicators, are better candidates for consciousness. But they also say in using these indicators, one should bear in mind how they relate to theories and to each other. So some combinations of indicators will amount to a more compelling case for consciousness than others. So this actually indicates that it's not the case that you can just count the number of positive indicators that are displayed by a system, and then the larger this number, the more probable it is that the system is conscious, or the more confident you can be that the system is conscious. But actually it's more complex because these indicators are not independent. Some positive indicators are only provide strong evidence if certain indirect negative indicators are also fulfilled. And so you really have to look at the combinations of indicators. Okay, but how can we specify a bit more explicitly how these indicators should inform or credence that a system is conscious? And this is work in progress, so I'm really looking forward to your feedback on this. There's one option which is similar to a suggestion by Jeff Szabo and Robert Long. So in a paper, they consider how likely it is that AI consciousness can be achieved by 2030 using a calculation that incorporates credences for a list of necessary conditions for consciousness. So they go through a list of possibly necessary conditions: biological substrate or function, embodiment, grounded perception, self-awareness, agency, and so on. So this is just an example, so just listing this for the sake of illustration, and then they specify the chances that these are actually necessary conditions, such that if a system doesn't fulfill these conditions, then it's not conscious. And they also specify chances that these will not be met by AI by 2030. Okay, then they compute the chances that they are not necessary and not met by 2030, and then compute the probability that AI consciousness can be achieved in the sense that there's no necessary condition that won't be fulfilled by any AI system. And it's 1 in 1,000, but it's just really an example to illustrate how you could estimate the probability here. And maybe something like this can be used just to specify how the presence of certain or absence of certain indicators should shape our credence that a system is conscious. So we could multiply the chances that conditions unmet by a system are not necessary for consciousness, and then so we'd have a bunch of conditions, and we note whether they are met, register whether they're met by the system or not, and also have an estimate of or confidence that these conditions are actually necessary, and then we can compute a lower bound for the probability that the system is non-conscious based on our confidence that the conditions that the system fails to fulfill are actually necessary. And maybe one could then say, well, if the probability that it's non-conscious is large enough, maybe higher than 95%, we could say, okay, it's too improbable that the system is conscious. We don't have to make any further investigations. And if the probability is not that high, or confidence that it's non-conscious is lower, then maybe we should do further investigations. And another example would be to follow what Dave Chalmers calls the theory-balanced approach, taking into account the predictions of multiple theories, and then balancing one's credence between them, perhaps according to evidence for those theories or according to acceptance of those theories. So you would determine whether the system is conscious according to the various theories, and then basically weight the outcomes with respect to your confidence that the individual theories are correct. Okay, or you could use Bayesian statistics, so you could just take as evidence whether the different indicators that we have are fulfilled by the system or not. And then one option would be to compute the posterior probability that the system is conscious given the evidence. And of course the question is, what would be the prior probability that the system is conscious? And another option would be to compute the base factor, which is the ratio of the likelihood that of the evidence given that the system is non-conscious, and the likelihood of the evidence given that the system is conscious. And of course, in practice, that might be complex if the probabilities are not independent. Maybe you can also use some of the information about the indicators to inform priors about the prior probability that the system is conscious. So I'm really not sure how fundamental these challenges are, but it's at least not straightforward to go from knowledge about which indicators are present and non-present to a rational credence that the system is conscious or non-conscious. Maybe you could even construct something like a scoring system. So in consciousness science, there's, for instance, the Glasgow Coma Scale, which can be used to assess non-responsive patients. But so my impression would be that it's currently too ambitious in the context of artificial consciousness, and I'm not even sure how one would do that. So one could maybe register which indicators are fulfilled by the system and which are not, and then assign some weight, some importance of the indicator, and somehow compute a final score that can then inform your credence that the system is conscious or non-conscious. So if any of you have suggestions how one could do something like that, I'd be glad to hear that. Okay, here's a graphical summary of the talk. So maybe the main take-home message is that when we try to assess the probability that an artificial system is conscious, it's not enough just to look for positive evidence for the presence of consciousness. It's not enough to look for positive indicators, as suggested by the AI consciousness report. But you also have to take into account what I call negative indicators of consciousness. And these are indirect negative indicators that shape the extent to which some positive indicators are probability raising, and direct negative indicators that are general constraints on artificial consciousness and are such that their absence can make it significantly less probable that the system is conscious, regardless of which other indicators it displays. Okay, thank you very much for your attention.